So this one here, we've been given the cosine, and again the quadrant is known. Okay, so since the quadrant is known, although the cosine can be in two different positions, we're only going to consider the ones that end up here. Okay, so it says find the reference angle and the standard position angle. So I want to undo this cosine, and again the input is a ratio. I never put ratio into the cosine. I put the ratio into the inverse cosine, and that's going to give me theta 1. Okay, so theta 1, when I work this out, so I do inverse cosine of negative 3 over 5, and I get 126.87 degrees. Okay, so that's somewhere around here. That looks about right because it's going to be negative 3, positive 5. Oops, so positive 5 is going to be along the radius, and that's going to be 126.87 degrees, which perfectly consistent with what we've been given. The problem is that's not the right quadrant. So how am I going to find the right position? Okay, so first things first, I'm going to just find the reference angle here. So I'm going to subtract that from 180. So my reference angle in here, that angle works out to be 53.13 degrees. Okay, so that's my reference angle. I need to really make sure I find the right position though. Okay, to find the right position, I've got to use the symmetry for cosine. The symmetry for cosine is folding across that horizontal line, and I know that's going to be negative 3, 5, and the angle in here is going to be 53.15. So I could use my reference angle and add it to 180. I'm going to do it slightly differently, and there's a formula for this, so I'm going to just use a formula. 360 degrees minus, because of the symmetry going in this direction, okay, I'm going to minus 126.87 degrees. Okay, so when I do that, I end up with 233.13 degrees, and that is in the right quadrant. So 233.13 degrees in quadrant 3, so that is a correct, I'm just going to get rid of this line here. Okay. That is a correct standard position angle. So that angle is in the right position in quadrant 3. And again, the position is the most important thing. We're locating position when we use this angle. So there it is. So the x and y coordinates said to find the circle in radius 5. I'm going to answer that first because this is radius 5. So if I use if I use Pythagoras, I get 5 squared minus 3 squared equals 4 squared. Now the position is negative 4, so it's very important that we keep track of that negative. So it's going to be negative 3, negative 4. It also asks, what's the position on the circle of radius 1? Well, circle radius 1 means that the cosine value is my x value, my x coordinate, my x position. So negative 3 over 5 is my position on a radius 1 circle. The cosine value becomes my position. The sine value becomes my y position. So my sine value is going to be negative 4 over 5. So in a radius 1 circle, it's going to be that point right there. What we could do is also just scale this down from radius 5 to radius 1, use proportioning, and make these two coordinates 5 times smaller, and we get those points as well. But it is good to understand the unit circle, that the unit circle allows us to use the cosine ratio and the sine ratio as actual lengths and position, and that's very convenient for to be able to do some more math on that.